Okay, so we're going to talk about area and surface area today. Remember, Thursday is the last day for you to hand in any missing assignments. After that, they go into zeros. Your mark's going to go down. Also, remember that Friday at 8:30 is when your final exam is here in this room. Okay, that's different than what's on the exam schedule. I'm away the last week in January, so I have to plan my exams a little bit early. So you need to make sure that you're here for your final exam. I'll be sending out an email today, another reminder today, and probably another one on Wednesday, just so everyone knows. Wouldn't be a bad idea to put it in your phone as in your calendar so that you remember. Yes, sir. Nope. Wednesday's the last day of classes. So exam week starts Thursday. Okay? So that means then on the day that the Block 1 exams are scheduled, which I can't remember what day it is up next week, I guess it'll be. You guys won't have to come to school that day that the Block 1 exams are officially scheduled for, unless they have a review session planned for the afternoon for your Block 2 class, because sometimes they do that. We just don't have that schedule yet. Okay? So Friday, first thing in the morning, here is your final exam. Yep, when you're done, you can leave. You bet. You have to stay for at least an hour, but yes. Block 1 exams are scheduled for Tuesday, January 24th. So according to the schedule, last day of classes again is this Wednesday. You guys will, Thursday there's Thursday, January 19th. There's nothing for you guys unless you're taking Social 10. If you're taking Social 10, then you have an exam in the afternoon of Thursday, January 19th. Friday, January 20th, in the morning, is nothing for you guys because that's English Part B. That's when you guys write your final exam. But in the afternoon is Social 20. So I doubt any of you are in Social 20. So that means you don't have to be here on Friday afternoon. Monday, January 23rd. In the morning is Social 30, as well as grade 9 stuff. Nothing in the afternoon. So you guys don't have to come here Monday, January 23rd. Tuesday, January 24th is when the Block 1 exams are scheduled for. So you guys wouldn't have to come on Tuesday, January 24th to school. Wednesday is Block 2 exam in the afternoon. Thursday is Block 3 exams in the afternoon. And Friday, the 27th, is Block 4 exams in the afternoon for you guys. Yes, sir. Yeah, you can come take a picture here. Should also be on the school website, Facebook page, I'm sure. It's all on there. Everyone say hi to Princess. Princess just logged on. Say hi, Princess.
Hi, Princess.
Okay, so here we go. Formulas for area may be used to solve measurement problems involving basic shapes and composite shapes. So what a composite shape is, it's where you have two objects kind of put together. And those composite shapes will consist of more than one basic shape, So we have some basic formulas for area. Area of a rectangle is length times width, or base times height. Now that's actually the same formula to find the area of a square, but the difference though is that with the square, all four sides are the same length. So it's common when dealing with a square that the letter S is used to represent the length of each side, the letter S. And then when you go S times S, you actually get S squared. Now again, you can say length times width, it's the same thing, but often when dealing with squares, that's what formula is used. For a triangle, you need to know the height of the triangle as well as the length of the base, because the formula for area of a triangle is base times height, all divided by 2. And for a circle, you need to know the length of r, the radius. The area of a circle is pi times the radius squared. So pi is an irrational number. It's approximately 3.14. You've seen it before. But it is an irrational number. It's actually a decimal that never stops. Brooklyn, give her a smack, Christy. Take out your earbuds. Okay? So that's the formula for area of a circle. Pi times the radius squared. So we can use these formulas to find the area of these different shapes. In the case of question A, that's a square. The length of each side is 5 centimeters. And we've seen that the formula for area of a square is S, the length of each side squared, which means you're going to square 5 centimeters. When you square the 5, remember squaring means multiplying a number by itself. It's 5 times 5. Not 5 times 2, 5 times 5, which is 25. As well, you're going to square the centimeters, which gives us centimeters squared. Area is always in units squared. Always. Right? In the case of question B, that is a rectangle. And we've seen that the formula for area of a rectangle is length times width, or base times height. So that'll be 8 feet times 5 feet. 8 times 5 is 40. And again, when you multiply feet times feet, you'll get square feet, or feet squared. Area is always in units squared. All right, so these next two are both circles. And the formula for area of a circle is pi times radius squared. The radius here is 2 centimeters. And you have to follow the order of operations, which says you're going to square the 2 first. Danny, put your phone away. When you square the 2, you're going to get 4. When you square the centimeters, you're going to get centimeters squared. And then you're going to multiply that by pi. And like we've always done, you don't want to use any rounding values as you're calculating an answer. Most calculators have a pi button on them. So I said it's approximately 3.14, but it's an irrational number. That decimal doesn't repeat, doesn't terminate. It just keeps going on forever and ever and ever. Never stops, never repeats. Okay, so you want to use the value of pi, not just 3.14, and multiply that by 4, which gives us 12.6 if we round to the nearest tenth, because I think that's what it asks us to do up above. Round to the nearest tenth when necessary. So approximately 12.6, and again, centimeters squared. Do you have the measurement booklet? It's over there. Now the difference with question D is with question D, you're given the diameter, not the radius. But the radius is half of the diameter. If you take the diameter and divide it by 2, you'll get the radius. So 8 inches divided by 2 is 4 inches. Again, the formula for area of a circle is pi times the radius squared. And we found the radius here to be 4 inches. That needs to be squared. Now, when I did the last one, I got the value of pi first, and then I multiplied by the answer when you squared the radius. But you don't have to do it in a couple steps. You can do it in one step. Most calculators will do order of operations. So you can see I've gone pi. Most calculators have a pi button, so you should be able to find it. And that's what you want to use. Times 4 squared. So you can see that's what I put in my calculator. The calculator will do order of operations. It'll square the 4 first and then multiply by pi. And when we round that off, we'll get approximately 50.3 square inches. Right, if you round that, it'll be 50.3. Right? And that'll be in inches squared. Okay? So these next two are triangles. And the formula for area of a triangle is base times height divided by 2. So we're going to have a base of 4 meters times a height of 5 meters, all divided by 2. So you're going to have to get the top first. 4 times 5 is 20. And meters times meters is meters squared. And then that's divided by 2, which will give us 10 meters squared. So there's the answer for the area. Now here's what that means, okay? We haven't talked about this, but here's what that means. If you took a square that measured 1 meter by 1 meter, 10, our answer would be how many of those 1 meter by 1 meter squares it would take to cover that shape up completely. It is true that some of those squares would have to be cut off, and that piece would have to be placed somewhere else, but they would all fit. That's what area means. In this case here, 10 square meters means if you had 10 squares that measured 1 meter by 1 meter, that's how many it would take to cover that shape up completely. And again, you'd have to cut some of those squares apart to make them all fit, but they would. There'd be nothing left over. It would cover that triangle up completely and exactly. No overlap anywhere, or no extra pieces sticking out. All right? So looking at the next one, again, it's a triangle. Formula is base times height divided by 2. In this case, the base is 8 inches. Our height is 10 inches. And that's divided by 2. So 8 times 10 is 80 inches squared, because you're also multiplying inches by inches. And when that's divided by 2, you'll get 40 square inches. So again, if you had 40 squares that measured 1 inch by 1 inch, 1 inch wide by 1 inch high, it would take 40 of them to cover up that triangle completely. Again, you'd have to cut some of those pieces up to make them fit, but all the chunks would fit and cover that triangle up exactly. There'd be no extra left over. That's what that means. So these next two are examples of these composite figures we talked about. The first one is made up of a rectangle and a triangle. So if we say the rectangle is area 1 and the triangle is area 2, we'll find the area of each of them and we'll add them up. Now, if we look at this, the entire base of this shape is 14 centimeters. The rectangle is only 6 centimeters wide, so that means the rest of the 14 has to be for the triangle. Now, this one is not drawn to scale because if you use the numbers, the base of the triangle would have to be 8 centimeters because, again, 8 plus 6 will give us this 14. And it certainly looks like the triangle base is shorter than the rectangle base. So this one's just not drawn to scale. That's all that means. Okay? So area 1, the rectangle, is base times height. A base of 6 centimeters and a height of 5 centimeters gives us 30 centimeters squared. So there's the area of the rectangle on the left. Area 2, the triangle. Formula is base times height divided by 2. You see, a triangle is just a rectangle that's cut in half by drawing a diagonal. That's why these two formulas are so closely related. A rectangle is a base times height. A triangle is a rectangle, or maybe a square, that is cut in half using a diagonal. So that's why it's base times height divided by 2. It's half of a rectangle with the same base and height. So again, we determined that the base of the rectangle is 8 centimeters times the height, which is also 5 centimeters, over 2. 8 times 5 is 40 centimeters squared over 2, which is 20 centimeters squared. And so we'll find our total area by adding these two together. The rectangle was 30 centimeters squared, plus the triangle of 20 gives us a total of 50 centimeters squared. So what that means, if you had little squares that measured 1 centimeter by 1 centimeter, it would take 50 of them to cover up that composite shape exactly. Yes, you'd have to cut some pieces apart, but all of the pieces would fit and cover up that shape completely. There'd be no extras and no overlap. Question H. Again, we've got two shapes here. The first shape, area 1, is a rectangle, which we just had in the previous question. But the second shape now is a half circle, a semicircle. So we're going to use a formula for area of a circle, which already has a divided by 2 in it. Is base, or I'm sorry, that's not correct. It's pi r squared, which we'll have to divide by 2 because this is only half of a circle. So area 1, again, is a rectangle. The formula is base times height. Base of 12 centimeters, a height of 6 centimeters, and 12 times 6, 72, I think. Yep. So there's the area of the rectangle. And then we have, again, area 2, which is a half circle. Formula for area of a circle is pi r squared, but we have to divide that by 2 because it's only half of that circle. And what we're told here is that the height of the rectangle is 6 centimeters, which is also the diameter of the circle. So we have to use r, the radius, which would be half of 6. The radius would be 3 centimeters. So it's pi times 3 centimeters, all squared, all divided by 2. So again, you can do this in your calculator. Pi times 3 squared divided by 2. So that's approximately 14.1. And again, that'll be in centimeters squared. Because the area of a circle involves the number pi, which is an irrational number, a non-repeating, non-terminating decimal, our answer is irrational, a non-repeating, non-terminating decimal. So we have to round it. And that's why I use approximately equal to. Okay? So related to area is surface area. So the biggest difference is that with area, you're just looking at a shape drawn on a page. It's two-dimensional. When you're talking about surface area, it's three-dimensional. It's the area of all the faces added up. Okay? So we've got some formula for surface area. And again, you're going to get a formula sheet that has all these formulas on it. So you don't have to memorize any of them. You'll get a formula sheet with all these formulas on it. So a rectangular prism is a box. A box has a length, a width, and a height. The surface area is the area of all the faces added up. So if we look at the front piece, that is a rectangle that measures L long by H high, length and height. So there's that piece that you can see at the front, but there's also a piece on the back side that you can't see. There's two of those rectangles. So SA for surface area will be 2 times the length times the height. So that's the front and the back. You have a top that measures L times W, but the bottom is the same, so there's two pieces that measure L times W. And then you also have the left and the right side. The right side is width times height, W times H. The left side that you can't really see is the same, so there's two sides that measure W times H. So this is a formula we can use to find the surface area of a box, a rectangular prism. And then sometimes what you'll see is they'll factor out a common factor of 2 because each of these terms has a 2 in it. And if you divide each term by 2, that's what you get. Okay, so looking at the next one. A cube is a box where all the dimensions are the same. It's made up of 6 squares, 6 faces, and they all have the same dimension. So remember when we talked about squares, we said that the dimensions are often represented by S times S. Now in this case, there's a third one. You have a length of S, a height of S, and a width of S. So there are 6 faces, 6 squares, that each one measures S by S, or S squared. So the formula for surface area of a cube, which again is a special box where all the dimensions are the same, the surface area will be 6 times S squared. All right, so this next one is a triangular prism because the ends are triangles. The first shape at the top was a rectangular prism because the ends were rectangular. So a prism is a three-dimensional object that has rectangular faces, but the ends sometimes are different shapes. In this case, the end pieces are triangles. That's why it's called a triangular prism. So a triangular prism has a length, it has a base, and it has what's known as S, a slant height. Okay, it's kind of along the edge of that triangle. So if we look at those edge pieces first, or those end pieces first, I should say, they're triangles. And the formula for area of a triangle is base times height divided by 2. So we also need to know the height of this. So base times height divided by 2. However, there are 2 of these because there's the face that you can see, but there's also a face on the back side that you cannot see. So I'm going to put a 2 in front of the base times height divided by 2. So that'll be the 2 end pieces. Then you're going to have a bottom piece, which is L times B, and there's only one of those. And then you're going to have the 2 sides, the left side and the right side, and they measure L by S, but there's 2 of them. So you can simplify this a little bit, because in the first term, the 2's will cancel, and you're just left with base times height plus length times base plus twice length times s, which again represents the slant height. So there's the formula for the triangular prism. This next one is a cylinder. That's basically a soup can. You with this, Riley? That's what that is. And the formula for surface area of a cylinder is 2 pi r squared plus 2 pi rh. That's the formula for surface area of a cylinder. 2 pi r squared plus 2 pi rh. And you'll sometimes see it written like this by taking out a common factor of 2 pi r. It'll leave us with r plus h inside the bracket. Sometimes it's important to know where the different parts of the formula come from. The first part of this formula, the 2 pi r squared part, comes from the fact that the bottom and top are circles. The formula for area of a circle is pi r squared. In this case, there's two of them, a top and a bottom. That's why it's 2 pi r squared. So that leaves with 2 pi rh for the area of the side of the cylinder. And it's important to know that, because you may see a question where maybe it'll be a cylinder, but there's no top, only a bottom. And so that means there'd be only 1 pi r squared there instead of 2 pi r squared. Okay, so important to know what the different parts of the formula are and where they come from. Princess left the meeting. Everyone say goodbye, Princess. All right, the last one is a sphere, which is a ball. And the formula for surface area of a sphere is 4 pi r squared. We know the formula for the area of a circle is just pi r squared. For a sphere, it's 4 pi r squared. So obviously a sphere is like 4 circles when you talk about the shape. Say hi to Keen for me, Princess says. Okay? You'll be given it. It's from the very center to the outside edge. Yeah. So for this first one, it's a cylinder. We want to find the surface area. The formula for surface area of a sphere, or excuse me, a cylinder is 2 pi r squared plus 2 pi rh. So the radius is 2 meters, which has to be squared. And that number appears in the second part of the formula because it's 2 times pi times r times h, the height, which is 6 meters. We're given all that. And once again, your calculator will do order of operations. You can put this entire expression in your calculator. Whoops. Try that again. Here we go. 2 pi times 2 squared plus 2 pi. And notice I'm just putting 2 pi in my calculator. That means 2 times pi. Times the radius of 2 times the height of 6. And if we round this to the nearest tenth, it'll be approximately 100.5. And remember, area is always in units squared. 100.5 meters squared. So again, that means if you took squares that measured 1 meter by 1 meter, it would take 100.5 of them to cover this shape up completely. The top, the bottom, all around the side, we take 100.5 of those squares that measure 1 meter by 1 meter to cover it up exactly. All right, the next one, that is a rectangular prism. It's a box with rectangular faces. And the formula for surface area we had written down was twice length times the width plus length times the height plus width times height. It's normally easier to use the factored formula than the original, but it doesn't matter, they both will work. So in this case here, if we say that L the length is 7, W the width is 2, and H the height is 3, L times W would be 7 centimeters by 2 centimeters, plus length times height is 7 centimeters by 3 centimeters, plus width times height would be 2 centimeters by 3 centimeters. So if we do inside the brackets first, 7 times 2 plus 7 times 3 plus 2 times 3, that'll give us 41 inside the brackets. And that again is centimeters squared. Multiplied by 2 would be 82 centimeters squared. So there's the formula, or there's the surface area of that rectangular prism. That's how many little squares measuring 1 centimeter by 1 centimeter it would take to cover up that prism completely. All right, the next one is a cube or a box, and we saw that the formula is 6 times s squared, where s is the length of each side, and in this case that is 4 inches. Again, our calculator does order of operations for us. We can go 6 times 4 squared, and we'll get 96. Exactly. Don't have to round that one off at all. Square inches. Right? And this last one is a sphere. It's a ball. And the formula for surface area of a ball is 4 pi r squared. The radius, we are told, is 9 centimeters. Once again, we can put this in our calculator, get it all in one step, and we get 1017.9. And again, because you're squaring the 9 centimeters, the centimeters is also squared. Area is always in units squared. This next one says that one style of a barbecue cover is in the shape of an open-ended rectangular prism. You see, there's no bottom here, because otherwise how could you cover your barbecue up if there was a bottom piece? It's hollow, and there's no bottom. So to determine the area of the material needed for the barbecue cover, again, note that the cover has no bottom. So we have to adjust our formula a little bit here. Right? Normally the formula that we use to find the surface area of a rectangular prism is twice the length times the width. Actually, let me do it this way. Twice length times width plus twice width times height plus twice length times height. That's normally the one that we start with when we're dealing with the surface area of a box, a rectangular prism. But in this case, okay, again, so if we label that as, H, the height. This is the length. These are the widths. So we've got a top which measures L times W, but there is no bottom. So that means there's only one L times W. So I'm crossing out the 2 in front of the L times W because there's only one L times W, the top. There's no bottom. Right? So we're adjusting the formula to match the shape that we have. So L times W would be 2.5 meters by 0.75. And just to save some room, I'm not gonna put the units in here as I write this down. There are 2's for the other ones though. The width again is 0.75 times the height of 1.5 plus twice the length, which is 2.5, times the height, which is 1.5. So again, we can do this all at once in our calculator. 2.5 times 0.75 plus 2 times 0.75 times 1.5 plus 2 times 2.5 times 1.5. And there's our final answer. And instead of rounding it, I'll just write it all down because it is a terminating decimal. So 11.625, and that'll be in meters squared. Square meters. So again, if you had squares that measured 1 meter by 1 meter, that number represents how many of those it would take to cover up that shape completely, all the faces. Surface area is finding the area of all the faces added up. This last one, a globe which is in the shape of a sphere has a diameter of 18 inches, which means the radius is 9 inches. And remember, the formula for surface area of a sphere involves r, the radius, 4 pi r squared. Approximately 71% of the globe is to be painted blue to represent the Earth's surface that is covered with water. Determine the surface area of the globe that is to be painted blue. So it's going to be 71% of the surface area of the sphere. The formula for surface area of a sphere is 4 pi r squared. And then we're going to have to multiply that by 0.71, which represents 71%. So it's 4 times pi times the radius, which is 9 inches. And again, that needs to be squared. And after we're all said and done, we need to multiply that by 0.71. So 4 pi times 9 squared is that number, 1017.9 approximately. So I rounded it to write it down, but I'm keeping that number in my calculator to multiply by 0.71, which you want to do. You only want to round off your final answer. Do not use rounded values when you're calculating answers. So 722.7 when we round to the nearest tenth. And that would be in inches squared. So that is the portion of the globe that would have to be painted blue to represent a part of the world that's covered in water. Okay? All right. So I'm going to hand out the assignments for 7.3 and 7.4. I will post the solutions on Google Classroom so you can check your answers. Remember that Friday is the final exam, Friday morning at 8:30 a.m. So make sure you remember that. Put it in your phones so you don't forget. Yes. So you need to give me a list of what you need. Yes. These assignments are not for marks. I'm putting the solutions on Google Classroom.